momentum is rate of change of momentum is the force, and the Newton's second law quantized that force, magnitude of that force, and momentum quantized the motion. The statement is well known to us, that is, the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. So force is proportional to change in momentum by time taken. If force F changes the velocity of a body of mass m from v to v plus del v, then its initial momentum, which is p equal to m into v, will change by del p, change in momentum, is equal to mass times of change in velocity. So here change in momentum, and now the time if we use at time t, then after time t plus del t, then we can say F is proportional to del p by del t, or F equal to proportionality constant k del p by del t. So F equal to, now if this time is small, that is if we check the limiting value, limit del t tends to 0, del p by del t is dp by dt. So F equal to k dp by dt. And if k is 1, then what we can write here, F equal to k d by dt. Here see, it is mv. What is mv? It is the momentum. And now here mass, for a constant mass, what will be the force? It will be km dv by dt. And now dv by dt is acceleration. In SI unit, k is 1. So how the constant k is taken 1? If a force of 1 Newton is applied to a body of mass 1 kg, produces an acceleration 1 meter per second square, then k equal to 1. So F equal to mass into acceleration. This form we have learnt in class 9, except the vector notation. Now from the second law, we can say acceleration is F by m. Now the acceleration produced in a body is directly proportional to the force acting on it and inversely proportional to the mass of the body. So here see, if we hold a pen in our hand, then the gravitational force on the earth due to the pen and gravitational force on the pen due to earth, these two are same. But if we release the pen will go towards the earth. Reason is, more acceleration will be on pen due to its less mass. This force is equal. So if the mass is less, then acceleration will move. Now about the force, it is a vector quantity. Force can effect of force, it can cause acceleration or deceleration, that is retardation. Accelerator of a car accelerates and its brake decelerate. Its SI unit is Newton. Remember, when we write the unit of a physical quantity which is in the name of the scientist as a full, then first alphabet must be small. If we write only the first alphabet, then that must be the capital. Now what is 1 Newton? 1 Newton is the force which, when acting on a body of mass 1 kg, produces an acceleration of 1 meter per second square in it. Now some points we should note about the second law. If F equal to 0, then A equal to 0. Means no acceleration. So what does it mean? If body is at rest, then that will remain at rest. If body is uniform motion, then that will remain in the uniform motion. So the second law is consistent with the first law. Now it is a vector law because F equal to dp by dt or F equal to mass into acceleration. So the second law is a vector law. Now here see how it is. Along the x-axis, Fx is equal to, means if a force is applied along this, F is applied, then along this it is the x-axis, y-axis, let here it is the z-axis. Then this force which is acting on a body can be independently found along this axis, x-axis, along y-axis as well as along z-axis. So that is Fx equal to dpx by dt, or it is mass into acceleration along x-axis. Similarly, it can be resolved along y-axis and z-axis. It means that if force is not parallel to the velocity but makes some angle, it changes only component of velocity along the direction of force. The component of velocity normal to the force remains unchanged. That is, the motion in a projectile under vertical gravitational force, the horizontal component of velocity remains unchanged, that we have seen in the projectile motion. This equation F equal to dp by dt or m into a is applicable to a single point particle. But again see, in our daily life, rarely we will find a single point size particle. Then how? Then in class 11 we will learn system of particles, and to describe the laws of motion we will develop a concept of center of mass. So that's a point size particle. Now the impulse. What is impulse? When a ball hits a wall and bounces back, the force on the wall by the wall acts for a very short time. When two are in contact, yet the force is large enough to reverse the momentum of the ball. Means see, when a moving ball hits a wall, for a short duration they remains in contact, and the wall exert a force on the ball so that its direction reverse back. So this what happens? A moving ball before hitting moving in one direction, when it reverses, its direction changed, so its momentum changed. Means the product of force and time, how much force applied by the ball in how much time, that is called impulse. And how the impulse can be measured, that is change in momentum. And change in momentum is a measurable quantity, because a wall, how much force a wall applied we can't measure. But we can measure the change in momentum of the ball. So if ball was moving with velocity v of mass m, then its change in momentum will be twice mv. And if this twice mv taken place in time t, then this can be measured. So product of force and time can't be measured always in all situation. but the change in momentum can be measured. And this product, force and time, is called impulse. So impulse is equal to force into time, means large force acts for a short time, which is equal to change in momentum. And such force is called impulsive force, which is denoted by J, J equal to F into T. Now here see the importance of impulse in practice or in practical life. A high jumping or long jumping athlete is provided either a cushion or heap of sand on the ground to fall upon. This increases the time in which momentum comes to zero. You might have seen buffers or thermocol, plastic sheets, straw, paper are used as packing material, especially for packing glassware, chinaware, electronic devices. The reason is increase the time in which momentum comes to rest. Means it decreases the rate of change of momentum. So decreases the force. Shock absorbers are provided in vehicle to allow more time during the bumps and jerks. A seasoned cricket player stops the ball by drawing his hand along the direction of the ball. By this means he or she allowing more time so that he or she has to apply less force. Here see, the hand is in the direction of the motion of the ball. A fast moving cricket ball has a large momentum. In stopping the cricket, its momentum has to be reduced to zero. This is all about the Newton's second law of motion.